Hi, everybody. Welcome to those who are already here. As I say pretty much every week around this time, the door into the Zoom webinar is apparently a single file door. And so we'll wait a moment or two for people to trickle in. And of course, on July 24th, no one's supposed to be on time to anything. So we'll give it just a minute or two. We'll probably start around 3:33. All right, everyone. It's 3:33. I imagine more people are going to come in the coming minutes, but I have some initial announcements to make, and quite frankly, no one came to see me. So I'm going to do that quickly, and then I'll turn over to the panel, and we'll get going. So, hello, welcome, happy Friday. Welcome back to the Smart, Equitable Commonwealth, co-creating the society we want. My name is Dan O'Brien, and I'm the director of the Boston Area Research Initiative. And this is the 13th week of our conference. It's a fun year where you can actually say the words 13th week of a conference. And we are here and we have an exciting discussion today about pollution across communities and places. And to be honest, I'm a little bit excited because this is our last topical panel. We will end next week with a final closing keynote, which many of you have probably seen the announcements for. We are nicknaming it the Mayor's Panel, though the formal title is What Cities and Towns Need Now. And it's going to be a final discussion with Mayor Walsh from Boston, Mayor Spicer from Framingham, Mayor Rivera from Lawrence, and Town Manager Bartha from Danvers. And we'll have the Executive Director of the Metropolitan Area Planning Council, Mark Drayson, providing a regional perspective. And that will be moderated by Sid Espinoza, the Director of Philanthropy and Civic Engagement at Microsoft. And we're really excited, as that to us is a real way to cap this conference, as we've had weeks of conversations about data, research, technology, and the city, quite frankly, and the cities around Boston, towns, etc. But under the conditions of a pandemic, this gives us a real opportunity to close up with a call to arms of what needs to be done in the next year. What do cities and towns need from the research policy community right now? So we're very excited for that. So please join us then. Now, another quick reminder or two, quickly, the podcasts for our first 12 panels are now available through Apple Podcasts, Google Play, Spotify, Stitcher, and SoundCloud. This is also where you will find all future podcasts, being the one today and the one for next week, and they'll be released each Friday, so be sure to subscribe. And also, just one last reminder, we are no longer doing the happy hour for now, so there's no happy hour today, but we will do the happy hour one last time next Friday as a closing reception. So we'd love to have you all join us there. To today's panel. pollution across communities and places. As my students would probably be more than happy to tell you, I have been opining a lot over recent months and years about communities and places, and how there's this real interesting question of what is it we're experiencing? Is it a neighborhood, or is it a street, or is it our address, or all of them at the same time? And this has been a very common theme in criminology, which is where I tend to study it most often personally, but it's really become apparent in all sorts of fields. And today's panel I find really exciting because it captures that same kind of spatial tension for a very particular phenomenon, being pollution. We're going to see talks that are very much about neighborhoods, and we're going to see talks that are very much about being in one's own personal space, and the exposure to pollution in each of those locations. And so I find this just a fascinating aspect of something that we're able to see more and more often with increased power in GIS and more precise data and data collection tools, so on and so forth. So I think that I'm really excited about this panel. I'm really excited to think about the different ways that we experience exposure to pollution at different geographic scales, and quite frankly, the implications of that for equity and outcomes and health and all of those things. Now, that's a very academic 100,000 feet sort of view of the problem. I'm going to turn it over in a moment to our moderator, Paulina Muratori, who will make this far more tangible, as she is a real domain expert on this. She is a senior campaign organizer for the Clean Transportation Program at the Union of Concerned Scientists. She has a long history of thinking about what a low carbon future might look like and how we get there. And she now leads campaigns from Maine to DC on reducing vehicle emissions. And as we know, those emissions are the leading cause of pollution in cities, the pollution that we experience every day when walking down the street. And she offers a national perspective, something we don't always get here at BARI. We often do things very locally, in part because, well, we're often in person. But this year, the online medium has brought some benefits, and one is we can get someone who is a national expert to help shape this conversation with us for today. So I'm going to turn it over to Paulina. Before I do that, just real quick, a reminder that we are monitoring the Q&A. We're also monitoring Twitter if you want to tweet at us at BARI Boston or hashtag BARI 2020 for the conference. And with that, I'm going to turn it over to Paulina.
Thank you so much, Dan, and thank you to the whole team at the Boston Area Research Initiative for hosting this long series of the conference and having us here for this panel today. As Dan mentioned, I'm a senior campaign organizer in our transportation program with the Union of Concerned Scientists. I'm actually based in the Boston area, so this is all very close to home, but UCS is indeed a national organization. The primary focus of my work is transportation, which, as you all I'm sure are familiar with, is a complicated sector. It's also the largest contributor to greenhouse gas emissions, both in Massachusetts and in the entire country. So really, when we think about reducing emissions and creating cleaner, more equitable communities, neighborhoods, states, we have to tackle transportation. And I think that what we all know in addition to that is that transportation is a deeply inequitable sector due to decades of decisions about where to place highways, where to build new transit lines, where to build housing. And all of these decisions have left many communities breathing disproportionate levels of air pollution from transportation. Last year, UCS embarked on a study to actually try to quantify where that pollution from transportation is happening the most. And what we found in Massachusetts is that communities of color breathe about a third more vehicle pollution than do white residents in the Commonwealth. That is not a surprise, but really quantifying that number is something we've focused on, and we're continuing to kind of dig through that data and use it to inform policy and push our policymakers to do better. So I think this panel today is incredibly relevant and important as we continue to think through pollution across communities and places. And before I start, I do also want to acknowledge the changing landscape around us with both the COVID-19 pandemic and a reckoning around racial justice reshaping the dialogue around all of these issues. And I'm really excited to hear from all four panelists and then dive into the Q&A. So first, we'll hear from Lily Perkins-High, who is an analytical services manager at the Metropolitan Area Planning Council. In this role, Lily coordinates the efforts of the analytical services team within the data services department in providing customized data analysis and mapping for MAPC planning projects. Her specialties include analysis of tabular and spatial data, written and visual presentation of findings, and project management. In her talk today, she will focus on an MAPC publication that used data from the Massachusetts Vehicle Census to estimate municipal greenhouse gas emissions from transportation. Take it away, Lily.
Thanks, Paulina. Great. I theoretically am sharing my screen. Can I get a confirmation of that? Oop.
Not seeing.
How about now? Okay, great. That is a much practiced exercise and one that I am only partially successful in doing on a regular basis. So I'll begin. Good afternoon. Once again, my name is Lily, and I am the Analytical Services Manager in the Data Services Department at the Metropolitan Area Planning Council, or MAPC. And I'm filling in today for my colleague, Connor Gately. Today, I'll be presenting about our use of the Massachusetts Vehicle Census in estimating municipal greenhouse gas emissions from on-road vehicle transportation. And I'll just say that in doing so, I'm presenting on behalf of a much larger team that includes Connor and my colleagues Meg Aki and Tim Reardon, among others. I'm confident that there are a number of people listening in who know far more about greenhouse gas inventories than I do. But for those that don't, I figured I would kick off with a slide defining what I mean when I use this term. A greenhouse gas, or GHG inventory, accounts for the emissions resulting from a defined geographic area in a given year. The why of this, of course, is that an inventory like this provides an understanding of how residents, businesses, and municipal operations contribute to a community's greenhouse gas emissions footprint, and in doing so can guide the actions of local decision makers and municipal staff and focus work to reduce greenhouse gas emissions. The process of accounting for these emissions is a challenging one. There are a number of guides, tools, and reports available to help, but we saw a need for a standardized approach for Massachusetts municipalities, which could be paired with a less resource-intensive data collection and data analysis process. To this end, this spring, MAPC released a new community greenhouse gas inventory tool and an accompanying step-by-step guide, which outline a Massachusetts-specific approach to calculating greenhouse gas emissions from the primary local sources of emissions within cities and towns. The methodologies applied in the guide and the tool are based on the recommended approaches in the Global Protocol for Community-Scale Greenhouse Gas Inventories, or the GPC. And I'll say that both guide and tool are available for download on our website. These resources cover the stationary, energy, transportation, and waste sectors, though today I'm focusing only on data related to on-road vehicles, which is a subsector of transportation. Trying to get my slide animation to work. The on-road vehicles subsector includes vehicles such as buses, cars, trucks, motorcycles, and on-road waste collection and transportation vehicles that collectively transport people, property, or material on public or common roads, thoroughfares, and highways. Calculating emissions for the transportation sector, as you might imagine, is a particularly difficult exercise, however, in part due to the challenge of assigning emissions to a particular geographic area, given that vehicles are moving around, and in part due to variations in data availability and in existing transportation models. For this reason, the GPC offers additional flexibility in calculating emissions from transportation and offers up 4 common methods. The first of these is the fuel sales method, in which emissions are estimated using the volume of fuel purchased within a city boundary. The second 2 methods, the induced activity method and the geographic method, use modeled vehicle miles traveled. The induced activity method looks at trips that are prompted or induced by residents within the municipality, while the geographic method looks at all on-road travel occurring within the municipality. This would include what I would describe as pass-through traffic. The fourth method, and the one we use in our resource, is the resident activity method. The resident activity method looks only at transportation activities undertaken by residents in the municipality. It generally does so using vehicle registration records and surveys. The data source we use for the tool for the resident activity method is the Massachusetts Vehicle Census, which is a catalog of information about vehicles registered in the Commonwealth from 2009 to 2014, which was created by MAPC in partnership with the Massachusetts Registry of Motor Vehicles. The vehicle census combines information from vehicle registrations, inspection records, mileage ratings, and other sources to document the ownership and mileage history of each vehicle. This information is then published in a series of geographic summary tables, which include data such as counts of passenger and commercial vehicles, effective passenger miles per gallon, and average daily passenger fuel consumption. Now, in the context of greenhouse gas inventories, we see three key benefits of this approach, which is kind of the pairing of the resident activity method with the Massachusetts Vehicle Census. The first, which I see as a general benefit of the resident activity method, is that it is policy directed, meaning that a focus on emissions produced from transportation activities undertaken by municipal residents is a focus on an area that municipal leaders could possibly influence. Municipal leaders are better able to develop local policies that influence vehicle choice and mode choice than they can develop policies that influence traffic passing through on 128. The second advantage is that the Massachusetts Vehicle Census is empirical data rather than modeled data that should, over time, reflect changes in vehicle use. It is also consistent over time and available throughout the region, which means that it can be used for year-over-year comparisons and for benchmarking. So how you might compare your municipality to another municipality. The final primary advantage of the resident activity method, is particularly in combination with the vehicle census, is that there's a reduced risk of double counting emissions across municipalities. A disadvantage of the resident activity method GPC is that it overlooks non-municipal resident traffic, a portion of which local policy could feasibly begin to influence. Within this category of non-municipal resident traffic by commuters, tourists, and other travelers, trucking and e-commerce, and rideshare. Second, while I would also assert that MAVC, the Massachusetts Vehicle Census, is a very strong record of vehicles miles traveled throughout the Commonwealth, we do apply fuel economy estimates to the mileages in this record. This means that it is not a vehicle by vehicle record of what is truly being emitted. It's an estimation based on these known or reported miles traveled. Third, the latest year of data available right now is 2014. Though we're very close to a final agreement with the RMV that would provide access to the vehicle registration and inspection record, we need to do an update. The timeline for processing that data is as yet to be determined. I feel like I could do a second 8-minute presentation on conclusions and policy applications of this work, but in the hope of staying under my time limit, I'll say that greenhouse gas inventories provide a baseline from which to measure progress and emissions reductions against, and a method for benchmarking the effectiveness of local climate mitigation programs and policies. The guide and corresponding tool reduce the work of a local inventory to around 15 hours of time, which makes this task, I believe, in arm's reach of municipalities throughout the region.
Great, thank you so much, Lily. We're going to save all questions for the end and go right through all of the presentations. So next up is Matt Raifman, who is a PhD student at Boston University, studying the climate and health co-benefits of urban policy. Today, Matt's talk will focus on quantifying the health impacts of eliminating air pollution emissions in the city of Boston. Matt, over to you.
All right, can you see that? Okay, great. All right, hi everyone. So as Paulina mentioned, my name's Matt. I am presenting some research that we recently published in Environmental Research Letters, and on behalf of my co-authors from BU and Georgia Tech. I did want to recognize the support we received from NIH, NOAA, and NASA in doing this research. And I'll move forward. Are you? Okay, great. So actually, as Lily was kind of just talking about with greenhouse gas emissions inventories, I kind of want to set the stage for this research with the background of the progress that's being made within cities. So if you're like me, when you think about climate action and policies addressing climate change, the first thing you might think about is actually not the city, but maybe the UN, right? The UNFCCC or the Sustainable Development Goals and whatnot. But there's actually a lot of exciting action happening in cities. And so by one account, this is from the US Fourth National Climate Assessment, about 450 cities across the United States have policies in place that are addressing emissions reductions. And that could be setting targets like abatement for greenhouse gas emissions or developing inventories like what Lily was talking about within the context of transportation. And what's interesting about these ostensibly greenhouse gas climate focused policies is that they also have the potential to impact health. And the way that kind of mechanism flows, or the way that co-benefits to health develop, is through the strategies in these plans. So if you think about the City of Boston Climate Action Plan, there's a series of strategies that are focused on greenhouse gas emissions reductions. For example, you might focus on the housing sector, transportation, zoning policies, energy, power use, things like that. And the reason why these are effective strategies is they reduce demand for fossil fuels, which emit greenhouse gas emissions, whether that's coal and natural gas in the context of power, or whether that's petroleum in the context of transportation. But what's interesting, the way co-benefits develop to health from this policy is that these reductions in demands are simultaneously improving air quality in ways that do impact our health. So particulate matter, fine particulate matter, which probably many of you have heard about, that kind of goes through our lungs and gets into our blood and affects cardiovascular and respiratory outcomes, as well as ozone, which we're all familiar with. Those outcomes, those local air pollutants are also impacted by the same strategies that are focused on climate action. And the end result of all of that is mortality and morbidity impacts from health. And so using that kind of co-benefits framework, we asked the simple question, what would happen if the City of Boston sort of achieved its ostensible goal of eliminating emissions by the year 2050? And the way that we approach that is to create two scenarios in a model domain. One is the current scenario, basically current air quality. The second scenario is what happens when we eliminate emissions coming from the City of Boston, but keep everything else the same. And the delta, the difference between those two scenarios, is our estimate of the impacts of the climate action plan. And the way that we did that was to isolate grid squares kind of in a climate model that overlapped with the City of Boston and eliminate emissions from those grid squares. I won't go into too much detail on the methods. I'm happy to talk about it if folks have questions and they want to get into the details. Essentially, what we did was use a climate modeling program called CMAC, air quality modeling program, to estimate the base case and the zero emission scenarios. And then we calculated the delta for fine particulate matter and for ozone. And then we plugged in those changes in air quality into the US EPA benefits mapping tool called BenMap to estimate the health impacts and the monetary value of those impacts. So as our results for air quality show, we saw changes in particulate matter concentration and changes in ozone across the entire domain that we looked at. And the particulate matter changes from eliminating emissions in the City of Boston are highly concentrated in the City of Boston, which sort of makes sense. But they're also evident across the entire domain that we looked at across Eastern Massachusetts. The biggest difference came in downtown Boston, where we saw a halving of emissions, of air pollutants, PM 2.5. And you might ask yourself, well, we eliminated emissions. Why do we not just see the elimination of air pollutants like PM 2.5? And the reason why is basically it's much more complicated than that. It has to do with latent emissions from other sources in the area, as well as atmospheric conditions. When we look at ozone and the impacts of ozone from eliminating emissions in the city of Boston, we see a much more complicated relationship. There's actually an increase in ozone concentrations in downtown Boston, as well as areas west of Boston, kind of out to central Mass, and out east into the kind of Massachusetts Bay or the Cape Cod Bay. But we do see reductions in ozone in some areas to the north and south of Boston. And again, I won't go into too much detail on why we see this interesting kind of like inverse relationship between ozone and PM 2.5, but I'm happy to talk about that if folks want to in the discussion. So taking into account those net impacts, the relative increase in ozone and the decrease in PM 2.5 across the region, we estimate what the impacts would be on mortality. And we estimate about 300 deaths would be saved every year from eliminating emissions coming from the city of Boston, from climate action in Boston. But interestingly, only about 2/3 of those deaths avoided are located in Suffolk County, which is home to Boston. And why that's interesting is because that means that the actions that Boston's taking to eliminate emissions just for its residents are having impacts on the entire region. We're seeing mortality drop in Middlesex County and Norfolk and Essex. We estimate that that mortality drop would actually be present in different magnitudes across the entire region that we studied. And that's a key kind of outcome of this analysis, is that the actions undertaken in Boston have impacts across the entire region. It's not just about mortality, it's also about morbidity and quality of life. And so we estimate fewer heart attacks, work days lost, asthma exacerbation cases, minor restricted activity days, and a number of other morbidity outcomes as well. And taking into account those morbidity outcomes and the mortality impact, we tried to estimate the savings per year, the monetary value of those health benefits. And over the entire region, that amounts to about $2.5 billion in savings per year. And just within Suffolk County, which is again home to Boston, we see about $1.7 billion of estimated savings per year. And that's notable because that's about 1% of the gross county product for Suffolk County that's coming just from the elimination of air pollutants and taking climate action. And finally, just to wrap things up, we stratified the mortality impacts by race and ethnicity, and we adjusted for population share. So these values that I'm presenting are per net deaths avoided per 100,000. And what's interesting about this is the deaths avoided for non-Hispanic Blacks are about 3 times the deaths avoided for non-Hispanic white. And the main reason why this is happening is because of the concentration of air quality benefits in the city of Boston and the relative diversity of Boston compared to the rest of the region of Eastern Massachusetts. But just because it's explained kind of by that diversity it doesn't eliminate the effect that we're seeing here, which is that air pollution in a local level is very substantially disproportionately affecting non-Hispanic Blacks compared to non-Hispanic whites. And taking action on climate change, again, focused on greenhouse gas emissions, is actually improving the health and well-being of these communities that are historically impacted by pollution. And so we see these air quality benefits as a key part of an environmental justice approach to policymaking. And with that, I will wrap up and look forward to the discussion.
Great, thank you so much. Next up, we'll hear from Edgar Castro. Edgar has worked over the past few years with the Environmental Sensors Lab, Boston Area Research Initiative, and Urban Informatics and Resilience Lab on a variety of projects, including studying environmental pollutants within the T. Today, Edgar's talk will focus on mapping environmental conditions experienced by riders of the T at high resolution. Over to you, Edgar.
Thank you, Paulina. All right, cool. So yeah, once again, my name's Edgar, and I want to talk today about something that we've been doing over at the Environmental Sensors Lab for the past few years, which is basically we've been trying to understand like what are the different environmental conditions experienced by people within the T when they're riding the T. And so the main motivation of this work is that the T is like a really important resource for people in the area, right? So according to the census data, about 34% of people primarily use public transit as their main mode of commuting. And of those people, 60% of those primarily use the subway. So according to the MBTA, that comes out to about 641,000 rides on the T every weekday. And despite how many people are riding the T and how important it is, we don't actually know that much about what goes on inside it because there's not that much publicly available data. And so the first part of our study was to kind of identify what quantities we actually wanted to look at. And we found this paper by Gershon et al., who was at Columbia University at the time, where she basically outlined the different environmental quantities that might be of concern to people riding subway systems, such as particulate matter and high levels of vibration and noise, and even going into things like stress levels and physical violence. And so in our initial literature review, we found a lot of studies trying to quantify these things on subway systems around the world. But something that we noticed is that these studies mainly focus on one quantity at a time, or a group of very interrelated quantities. And surveying subway systems in this way has like a really high opportunity cost because it takes a lot of work to set up like a sampling procedure and schedule that with the subway agency and then go out and do the actual surveying. So something that we wanted to look at was if we could develop a way of surveying multiple different quantities at the same time and kind of lower the cost of understanding subway systems. And so the culmination of that effort was the subway surveying platform that we created, which is basically just like a wooden platform with a bunch of different sensors attached, all measuring different things. So we had a cheap tablet computer that I was using to manually record the location and status of the train. We had a particulate matter sensor, a noise sensor, which was basically a microphone, a triaxial accelerometer that was recording vibration data, and then a general purpose data logger that we were using to record temperature, humidity, and lightness data. But the lightness data wasn't too useful because of how that was positioned underneath the noise sensor. And so with that system set up, the next thing to do was to decide on a sampling procedure. And for this, we consulted the MBTA Data Visualization Project, which is a really cool website where they basically took data from the MBTA and plotted how ridership fluctuates over time through a single day, and then also how it changes from day to day over the course of a week. And so we focus on two main sampling periods here. The rush hour time period, which was 7 a.m. to 9 a.m. on weekdays, which was important for understanding how the system operates under normal conditions when people are riding it. And then also the off-peak time period, which is after 9 p.m. on weekdays or on Saturday and Sunday. And this was important for understanding kind of the baseline readings of how the system operates without the influence of people. And it was this off-peak hour that we decided to focus on for our 2018 pilot study, encompassing all of the sensors that I mentioned earlier, because we just wanted to know, like, how does the system operate just on its own? And then in 2019, we followed up using mainly just a particulate matter sensor, because we thought that, for reasons I'll get into later, the particulate counts are a lot more susceptible to changes in passenger load. And so in 2018, when we did that pilot study, we were able to survey most of the system with the exception of the Quincy part of the Red Line. And on average, we visited each station about 3 times. And in 2019, when we followed up, that's when we were able to fully survey the entire system, visiting each station about 9 times. And so now moving into what we saw on those surveys. So as Matt mentioned, particulate matter is really important for cardiovascular health, and exposure to it for a long period of time could be potentially dangerous. And what we observed in particulate matter was that, as expected, it tends to concentrate in the downtown areas of the city, but it tends to concentrate a lot more on the Red Line than on the other lines. So the place with the highest particulate matter concentrations on the entire system is the area between South Station and Broadway on the Red Line, likely due to the proximity of South Station and that also being an underground section of the system. And then, as expected, we observed some temporal variations. So the median particle concentration that we observed was about half that of the half the rush hour concentration during the off-peak hours. And some possible reasons for this include the increased passenger load leading to more off-gassing, or just people bringing more pollutants onto the T, or stirring up the air and restricting the airflow because there's just more bodies, restricting the airflow. And then we also observed some directional variations in particle counts, and these particularly concentrate on the areas where the train is either underground and moving above ground, or it's above ground and it's entering a tunnel, which makes sense conceptually because when you're in the tunnel, there's nowhere for the particulates to go, versus when you're on the surface, there's not really that much staying inside the tea because it's just being released into the atmosphere. And these directional variations is something that we also observed in the other things that we measured, but we didn't look too much into potential causes for those. So moving on to noise, the distribution of loud sections for noise is a lot different than the distribution you saw for particulate matter, because here it starts to involve more of the orange and the blue lines. The loudest sections on the entire system were between Alewife to Harvard on the red line, Mass Ave to Back Bay on the orange line, and Andrew to Broadway again on the red line. And these are all the sections on the T where the median sound level was above 85 A-weighted decibels. And this is the level for which OSHA recommends an 8-hour exposure limit. Now, given that, this probably isn't too much of a concern to most people because you probably aren't riding the T for 8 hours a day. And even if you are, these aren't the majority of the red line or the orange line. So you're probably not experiencing those noise levels for 8 hours. On the vibration side of things, this is where we start to see a really different distribution, because this is mainly concentrated on the blue lines and the red lines. But what we see is that the vibration on the blue line is mostly attributable to forwards and backwards motion instead of side to side motion, and side to side motion, instead of on the red line that's mostly attributable to up and down motion, which is the one that's most responsible for people reporting discomfort when they're riding a subway system. And so the last thing that we wanted to look at was if any of these quantities were possibly interrelated, because just anecdotally, I feel like the loud sections and the sections with the most vibration seem to happen concurrently. But what we see is that that's not actually the case. And apart from the obvious relationship between fine particulates and large and coarse particulates, we actually don't see that much of a relationship between any combination of two quantities. And so something that I mentioned when I started this was that there's not really too much publicly available information that people can use to understand the conditions when they're using the subway. And so we created a website that's live now that people can log on and click on different areas and see what are the distribution of particles or noise levels on different stations and track segments throughout the system. And then we also have a separate tool where people can select two stations, and then it would find like the optimal route between those stations, and you can see how the concentrations in particulate matter or the temperature and noise vary over time. And so that's the state of the study right now. Some future directions probably include like looking more into the directional variations and the other modes like noise and vibration. Or we also collected some temperature and humidity data, but we didn't really look too much into analyzing those yet. And so for people who want to look at the website, that's live now, as I mentioned, and that's available at envsensorslab.github.io/subway-survey. And then the data, the surveying utilities, and the full source code for that website will be available at github.com/envsensorslab/subway-survey. And yeah, thank you.
Great, thanks so much. We'll now hear our fourth presentation, which is from Catherine Connolly. Catherine is an environmental health PhD student at the Boston University School of Public Health and a trainee in the BU graduate program in urban biogeoscience and environmental health. Currently, she researches indoor air quality, energy, climate, and health in residential and school settings, which is the focus of her talk today. Over to you, Catherine.
Is this good? Can everyone see it? Great. Thank you so much, Paulina, and thank you to BARI for having me today. My name is Catherine Connolly. I'm a PhD student in the Department of Environmental Health at BU School of Public Health, as well as an urban trainee, and I'm really looking forward to giving this talk today. So we heard a lot about transportation, and now we're going to switch a little more to housing. So today I'll be presenting on a co-simulated energy and indoor air quality housing model to inform decisions for retrofits and health. So to give a little background on these topics, indoor air quality is known to affect residential health through a number of factors. So things like cooking and smoking, cleaning, furniture products can all affect indoor air quality, and this can be balanced by different actions such as mechanical ventilation from HVAC and fans, as well as window opening. Now, window opening is a behavior that might be determined by where you live, depending on the ambient air quality outside your house. We know that in areas like Boston and other cities that we have an aging urban housing stock, and there's also this demand for increased retrofits with higher energy efficiency to meet carbon reduction goals and to reduce energy overall. However, depending on the extent of a retrofit, this can lead to trapping of pollutants inside, if not balanced with proper ventilation, for example. And climate action plans frequently talk about these energy savings, but the indoor air quality story at times can be missing. And this is very important to consider because people spend most of their time inside, and vulnerable populations are especially at risk in cases like this. And for people such as elderly populations, young children, as well as renters who might not have as much control over what happens in their homes. So a couple of years ago, collaborators at the National Institute of Standards and Technology, or NIST, and researchers in the Environmental Health Department at BU developed this co-simulation model for housing. So it combines these two programs called Energy Plus and CONTAM. Energy Plus is a whole building energy simulation program, which models energy consumption and water consumption in buildings, including homes, which was developed by the US Department of Energy. Whereas CONTAM is a multi-zone, multi-contaminant indoor air quality and ventilation analysis program developed by NIST. And this allows for a novel modeling framework between these two programs. So on one side, we have Energy Plus, which kind of runs the show based on the building structure and ambient conditions from meteorology and other ventilation aspects, that kind of thing, within the building, within the home. Whereas CONTAM has these defined airflows, and Energy Plus, because of its thermal properties and considering the thermal changes based on temperature and other conditions outside, will provide these dynamic temperature profiles to CONTAM, which is a required input. Whereas CONTAM has, as I said, the defined airflows, and with these temperature and pressure differentials will come pollutants. So this is really important to consider both of them together in modeling different scenarios. So Energy Plus will track energy use over time, whereas CONTAM will track contaminants such as everyone's favorite particulate matter 2.5 and NO2. And different types of scenarios can be modeled from this really cool framework that we have here. To go a little more into detail, Energy Plus, there are many different types of houses that can be modeled. In this case, here we have a mid-rise multifamily home, 4 stories, 8 apartments per story. You can also do things like double and triple deckers, which are very common multifamily homes in Boston, as well as single family homes, of course. And the side of CONTAM allows for multiple zones to be considered within a home. So actions like smoking and cooking in living rooms and kitchens potentially could have a greater impact on people spending more time in those rooms or having their bedrooms, say, be closer there than others. And this also has an impact in multifamily homes when we consider infiltration from your neighbor. So if you smell smoke from your neighbor, or you know what they cooked for dinner that night from the hallway, this is an action that happens called infiltration from a neighboring site. So this is another aspect that's important in considering multifamily housing exposures. To kind of round this up, to talk about the inputs of this model, like I said, on one side, we have the Energy Plus side, which will determine ventilation, insulation, different building materials, which will determine thermal properties of a building, whereas the CONTAM side includes things like building leakiness, which is a function of age of a building. Usually newer buildings have a tighter building envelope than older homes, as well as human behaviors like smoking and cooking, which are pretty common, and HVAC filtration, which I'm sure plenty of people have been hearing about recently with MERV filters, which can filter out certain pollutants. Finally, ambient conditions will have an impact on buildings. Temperature is one of the greatest predictors of energy use of a building. So meteorological conditions and outdoor pollutants such as PM 2.5 and NO2 and others can infiltrate into homes, especially in older homes, or through actions like opening windows. To give an example of this energy and indoor air quality trade-off, a former doctoral student in our department modeled many different scenarios for this mid-rise multifamily housing model. And here we have one of these examples, such as the change in total energy cost per apartment on the y-axis and change in total indoor PM 2.5 on the x-axis. So we're looking at both of these together, these changes, from a baseline scenario, which was a naturally ventilated multifamily home, to different types of retrofits. So weatherization would include things like sealing up the building and insulation, And weatherization and ventilation will include those, as well as balancing it with ventilation. So when we consider just weatherization, we will see a decrease in energy. However, this will lead to an increase in indoor PM 2.5, which, as we know, can be detrimental to respiratory cardiovascular health. However, when we include this ventilation aspect as well, there's actually a decrease in both energy and indoor PM 2.5. Now, this is one scenario as an example. There are many that you could model here. And this was for a standard ventilation, standard intervention in this type of model. So in conclusion, this co-simulation tool can inform decisions for indoor environments and energy use, considering many different factors that will play into the residential housing exposure, as well as identifying avenues of intervention for investment at different levels, such as home, community, and city levels in Boston and potentially in other cities as well. And this is important when we consider climate mitigation decisions with the goal of balancing these carbon emissions with retrofits, which we know can improve health in certain ways, but also including that indoor environment aspect and what's going on with air quality inside. Finally, we can also investigate another application is investigating historical housing policy decisions and how this has led to inequality in energy insecurity, indoor pollutant exposures, and most importantly, health. Additionally, in the time of COVID-19, we could think about the applications in limiting the spread of infectious disease and increased ventilation in homes and how that could have an impact on both residential health and energy. So to sum it all up, this is a very important tool that can have great implications for cities and thinking about different scenarios to balance this energy and indoor air quality story. And I would like to thank my collaborators and my funding from NSF and RT through BU Urban, and I'm looking forward to the discussion ahead. Thank you so much.
Great, thank you so much, Catherine, and to all the presenters for these talks. I think I love this combination of the four because we have some research that is incredibly granular, and we also have some sort of bigger picture pollution across time and space, things that we can dive into. So I'm going to start us off with sort of a broad question and would love to hear from each of you. I think we could just answer it in the order that you gave your presentations. And this question is sort of around how the world has shifted since you all originally submitted your presentations for this conference. We're deep in the middle of a pandemic, which is ongoing, and I'm afraid we have not yet even seen the worst of it. We know it has had disproportionate impacts on communities of color and continues to do so. And we're also in the middle of a reckoning around racial justice in this country. So given all of this, I'm wondering if you could each speak a bit about where you think we go from here and how this shifting landscape could change both your research and the discourse around it going forward.
I can start to respond to a piece of that very large question. I think one of the things that came up for me in hearing it is in the context of greenhouse gas emissions generally is this inequity in who is generating greenhouse gas emissions and who is experiencing the consequences of those emissions. And I think when I think about COVID and I think about racial justice, climate change hasn't gone away. It has been advancing over the past 6 months. And I think it's important that we can continue to kind of hold up our response to COVID and advance racial justice. And I think we also need to be focused on the fact that climate change is yet another injustice that exists on a global level. One of the things that's been coming up in our work recently is the notion of cooling centers. One of climate change and impact being extreme heat, one of the tools that we typically have in our toolkit to help relieve extreme heat is cooling centers. And that unfortunately is not a strong option this summer given the need for social distancing. And so I think I see all of these kind of forces coupled together. And I think the pandemic kind of pushes us to kind of think about kind of more and alternative strategies. And I'm also kind of eager for a time when we can kind of, once again, kind of deploy those existing resources on top of all of the good thinking and work that has been done over the past, I guess, few months of summer.
Yeah, just jump in. I mean, there's so much to unpack there. I think one thing is to be, and this is actually one of our PhD student colleagues mentioned this. I think we need to call out racism and structural racism in our research. Not in the way that we're approaching research, but in to some extent, though that is important, but in the way that we're analyzing our data. So I think, you know, there's, it's possible to look at like disparities in pollution or PM 2.5 and kind of stop at the point of recognizing that there are disparities. And actually, to be honest, that's kind of where we got to with our paper. We identified that there were disparities across race and ethnicity. But there's this potential to go a step further back, if you will, and try to unpack why those disparities are there. And I think that's kind of missing, at least from the research that I presented. And I think that's a lesson to be taken from the current times, both with the pandemic and also with racial injustice coming to the kind of forefront and in the spotlight across the country. But so that's on the research side. I think the way we approach research, we need to be more comfortable with calling out, you know, structural racism as an explanation for disparities that we're discovering in our research. The other thing, though, is this opportunity that we have with the world totally changing. I mean, it's exciting to some extent if you take a step back. Obviously, all the loss of life and illness and morbidity is terrible, but there's this opportunity to reshape the way that cities are run and the way that we operate cities and the priorities that we have. And I think that's the thing that we need to take advantage of from a policymaking perspective is, you know, how can we put into place the policies now permanently that are helping to roll back? And I think racism, and I think the main way that manifests in my head is around transportation, which I don't want to go into too much detail because there are others on the panel who might want to speak to that more. But I think we're seeing just dramatic swings in the way that people move around in Boston and elsewhere. And there's an opportunity to make those changes positive in a good way and to do it equitably. So I'll stop there.
Yeah, and I completely agree with both Lily and Matt. Like there's just like so much to do from where we are right now. And like there's like always so much talk about, you know, returning back to normal and like when are things gonna get back to normal. But like there's like a lot of problems with what was normal. And I don't see like why we should try to like go back to like a flawed system when we can start to take where we are right now and start building towards something better. But to address like the research part of the question, I think something that we really need to focus on moving forward is on mental health disparities, because like a lot of us know that there are very obvious physical health disparities, sometimes as a result of, like as Lily mentioned, people not having like the influence and power to resist a highway being built through their neighborhood, or like a giant mechanical plant moving in and out dumping chemicals into the air and water. But and like I'm glad that things like those are getting a lot more visibility right now among all like the racial justice issues that are like kind of like covering news feeds and everything. But I think we should really start paying attention a lot more to mental health disparities, because those do exist, and like communities of color don't have as much access to things like mental health resources, and probably like experience higher rates of like depression, anxiety, and we should be paying attention to that a lot more moving forward.
Yeah, great answers, everybody on the panel. Thank you for your thoughtful responses. To add to that, I guess, in terms of my own research, thinking about housing, and not just, I presented something that was more about the individual level of a house, but this can absolutely be scaled up. We could look at things like differences in exposures between historically redlined communities and others. And I'm sure we could imagine what direction that would go. But for the opportunity that this research and all of us working together in fixing this flawed system and addressing the injustices and the racist systematic approach we've had in this our whole society, I think there's great opportunity to work with communities to understand what people need, how housing exposure profiles could change for the better, how we can balance things like improving ventilation and improving quality within homes to improve residential health over time. And I think there's great opportunities for that. In terms of COVID, a lot of people are thinking about airborne exposure, of course, in schools, in their homes, in buildings. And this is a chance for us to revisit healthy building strategies overall. People are spending a lot of time at home. They're not going to work as much, or schools where they would have had, now they have a different exposure profile where they're spending so much time at home. Well, what does home life look like for certain people? And there's opportunities there to improve it across the board.
Thanks, everyone. Those were really great answers to a very big, complicated question. And I know we could probably talk for a long time about that. So, you know, one thing I think a lot about in my role and at the organization where I work is kind of translating or working with research and data and using that to inform policy and make change. And so I think at this point, I did want to mention, because it's very timely, that Massachusetts has a 2-year legislative session, which is about to end on July 31st, which is a week from today. And there are some really key pieces of legislation that address a lot of the topics that we've discussed today. One is a 2050 roadmap climate bill. And then even more important, I think, at the moment is a suite of environmental justice legislation that would redefine how the state identifies environmental justice communities. And within that, actually adds race as a criteria, which until now it has not. And the current definition that the state uses is very wide. And I can't remember off the top of my head, but it characterizes like a huge amount of the state as environmental justice communities. So really redefining what that means. And I think that gets at what a lot of you touched on with policies about where housing has been built, where highways have gone, which calling out race in those policies historically and starting to rebuild the way we think about policy getting done and actually focusing some of that back into these communities and giving decision-making power back to those who are most impacted. So I encourage everyone to check out that those bills. There's the House bill and a complement in the Senate. And if you feel so compelled, you can call your state reps and legislators and ask them to pass this important legislation along with the climate bill. So speaking of policymaking, I would love to just hear very briefly from whoever wants to chime in, kind of one policy solution that you think could help address some of what you've seen in your research. And then after that, we will still have time for, I think, maybe 2 more questions after that. So anyone who wants to jump in on that one can go ahead.
I can kick things off with a policy complication, which is unfortunately not going to be a perfect answer to your question, which is just a reflection in developing, working to develop this toolkit. One kind of challenge that came up over and over again was the notion of kind of displacement of emissions. If you're targeting vehicles and a suite of policies designed to reduce vehicle trips within your municipality, how are people getting around if you're targeting vehicles? How are they using public transit? Is public transit accessible? At what times? How much? Who is it accessible to? And so I think I don't have a policy recommendation in a kind of compact sentence or two, because I think in thinking about greenhouse gas inventories and vehicle movement within greenhouse gas inventories is a very kind of complex challenge of how you kind of hold up these dual goals of emissions reductions and equity, especially if you look at the kind of historical context of who these emissions generators have been. It's overwhelmingly people that are white, people that are upper income, and overwhelmingly countries like the United States. So I guess I'll conclude there and open it up to other folks.
Well, I'll hop in. I mean, I think action on climate action is itself fairly progressive because of all the issues we've kind of been talking about and many more around inequitable burdens at this point. So basically like moving the needle on climate action is itself often a very equitable action. And so I think that's really, to me, whether that's state policy or city policy or even county policy, it doesn't, all of those need to happen. We need to be reducing emissions across the board. We need to be thinking about how these policies are actually enacted and not just empty commitments. I think that's the thing that concerns me a little bit about a lot of this. I mean, Cambridge, just in the Boston area, Cambridge, Somerville, I think, Brookline, Boston, they all have climate goals. But are they going to hit those goals? And what strategies are they implementing? I mean, that's where the rubber meets the road. And that's where we really need to actually follow through. So if there's one thing, it's follow through, I guess. I think the aspirations are there. And the political statements are there and the commitments are there, but we have to actually follow through on those commitments if we're going to actually realize any of the change.
Yeah, absolutely. And if others want to chime in after this, feel free, but I think that's absolutely true. And one thing we're seeing is our great commitments across the board, and we need both the sort of legal and legislative infrastructure to allow change to happen. And we also need to think about how those policies translate into communities and who has access to what information. And, for example, you may have all heard I will not claim to be any kind of expert in natural gas, but you might have heard about the Brookline town ban on new natural gas infrastructure that was actually overturned by the Massachusetts AG's office this week, which seems like a sort of cognitive dissonance or some sort of like, what's going on here? But if state law is not changing at the state legislature to allow local changes, then we don't have the infrastructure in place that we need. And that's true for all kinds of things in transportation as well. Because transportation especially, you can't control where people drive and where that pollution is happening. But so definitely spot on there. Let me go to some questions that have come in. I have one here for Edgar. If you could I think you addressed this a bit, but the question that came in is, how do particulate matter, vibrations, and noise compare between subway lines and similar above ground transportation?
Yeah, so that's something that we wanted to look at into the the broader scheme of just surveying the public transit system as a whole. Unfortunately, we don't have that data, but I know just off the top of my head in the literature review, I believe there's a lot more noise and vibration in the trains, I think. I have to check on that. I don't have an answer off the top of my head. But for particulate matter, I think it's definitely a lot bigger in the trains because the trains spend a lot of time underground accumulating pollutants versus many of the buses spend most of their time above ground. So there's not really, the particulates aren't really trapped inside the vehicle. They have the opportunity to escape when the door is open.
Great, thanks. And I think we'll be able to send out information on all of these talks in case folks want to dive more into the findings and methods. So I think maybe one more question that I'd like to ask of all of you before we close for the day is around data and kind of thinking through if you could go beyond barriers that currently exist in data collection, to have more updated data or lived experience data from communities. What would you, what kinds of data would you love to have at your fingertips to help complete the picture that could help then lead to changes?
I'll start us off here. So I think having one thing that we talk a lot about in environmental health is having personal monitoring data, which can be very expensive and difficult at times to roll out in a very, very large fashion, right? So I think having some kind of like exposure monitor in a home and then attached to like a backpack when a kid goes to school, or in a on like sensors, right, like bracelets that we have. And one of our researchers in each department is using something called photo voice to capture people's experiences with heat. And I think that would be great to extend also to pollution and housing conditions. So I think about that kind of work a lot. So that would be great on the ground to have actual personal exposure and experiences for people living in different types of homes and in different parts of Boston.
Yeah, so I guess I'll go next. So something that I'd really want to be able to look at is like, so like as scientists and engineers, we tend to look more at like, I guess like more quantitative things, like how many pollutants are in an area, or like how often does a bus visit a certain place, or where is the bus going? But we don't really know too much about like stress levels. So, like I think some kind of survey where we could figure out like with respect to like the transportation system, like what are the highest stress areas in the system, so that we can work on figuring out what's causing that stress and maybe trying to make it just like a more pleasant experience for people in general.
Yeah, both of those ideas are exactly what I'm thinking about too. I mean, I think the personal monitoring thing is just such a wish list, and it would be so amazing because, just to know location information, what modes people are taking from a transportation perspective on a given day, and then what their exposure is, whether it's to temperature, air pollutants or stress. I think the stress thing is huge because, I mean, there are all these micro stressors that happen through the day, and we don't capture those in any respect. Like whether it's an almost accident on a bike, or a truck coming by or something like that. I mean, we can't capture that unless we have that individual time series data over the course of a day.
Awesome. Thanks so much. I think that's probably all we have time for at the moment, so I will pass it back to Dan.
All right, everybody. Well, thank you. That was a wonderful panel. Really enjoyed it. So thank you, Lily, Edgar, Matt, and Catherine for sharing your work with us and your expertise. And thank you so much, Paulina, for bringing your expertise to bear on kind of guiding us through the wilds of this conversation, as it were. I learned a lot, and I hope that our audience did as well. It was a wonderful conversation. So again, thank you all for sharing your work and for connecting all these different threads in terms of equity and other things that are kind of surrounding the dynamics of pollution, from mental health to stress to the individual experiences of each person every day as they move through the city. And thank you to the audience for joining us. As always, without you, we don't have a panel, we don't have a conference. So I hope everyone has a wonderful weekend, and we very much look forward to having everyone join us again next week for our final panel. The closing keynote, what do cities and towns need now? So one more time, a virtual round of applause for our panel, and thank you everyone for joining us.